So let's add like a constraint type of a thing, which is gonna override or match the rotation. Create a new script, call it match rotation constraint, and well, I think so, match rotation to target. I'm just gonna rename it as well so that both the file and the class are same. Define a private transform and serialize, of course, a constraint and the target, or the to match. Now we're gonna just create a new mono behavior, I custom constraints. This is useful, you'll see later. So make it an interface. It should contain a function for public void set weight, float weight, public void get weight, float weight again, public float rather, because you need to get the weight. We're just gonna implement it, and we should get the two functions required. Define late update and remove update. Define the weight, so a private float, serialized one, and that's just a basic header. Then we can set the constraint.local rotation is equal to match.local rotation every late update. Then we can define a matching type, so local and world. Then just going to define one variable for that, and a basic if statement. If this is local, then we want to do it like this with local rotations, otherwise with the real world rotations. Save that. Now we can make use of this function. So to get the weight, we just return the weight, and to set the weight, we can just set the weight. So this dot weight equal to weight. Just add a space for making it better looking in the editor. Some spaces, and just maybe add a tooltip. So the object which will be called matched. The object to match. And this is the matching type, local or world. Tooltip for the weights of the matching. Now we can add a method.lerp function, and just from the constraint.local rotation to match.local rotation, and based on the weight, we use quaternion.lerp in both cases. So this will actually put our weight in effect. So now we will make use of this actually. So duplicate it, put them all down, disable the game object, set the weight to 0. Cool. Duplicate, select all of them, and just disable them. So you'll delete them afterwards. We can remove all the components and add our own component on the normal ones. Similarly for the right hand. Now let's just assign all targets. So let's open up all of the left hand targets, constraints I mean. So just gonna assign them one by one, as you can see. Ring 2, ring 3, thumb 2, thumb 3, and that should be it for the left hand. Now let's move on to the right hand. Well, rather first we attach all the targets, then we'll think about the right hand. So there you are, assigning all the targets. Yep. And that's done. So now we go to the right hand bone and open up all that bones and assign them, so one by one. Ring 2, ring 3, thumb 1, thumb 2, thumb 3. Okay, cool. Now for the targets, so we'll move on to the targets. Assign each target as well. Once that's done, yep, and the last one. Cool. Alright, so let's fix the constraint weight modifier to support our custom constraints. First of all, as you can see, we need to be able to identify it. So else if constraint is equal to null, or rather, let's just check one more thing. So constraint dot, don't have anything ready, obj, the object dot get component, I custom constraint is not equal to null. Then we can define the constraint equals to object dot get component I custom constraint, and because this is actually a type of rig constraint, we can define two different variables here. So there you are, rig constraint, custom constraint. Cool. Then we can say constraints dot add, and just add that. We define a new list just to duplicate list. This is custom constraint, that is rig constraint, and we'll just close the rig constraints, or clear them, sorry. Then when we get the affected constraint, we pass in rig constraint. Not really used anyway up till now, but it's okay, just keep it there. Then we can actually just make a new function and change that one first to rig and this one to custom. There you are. The two will return different constraints. Alright, now we can add a for each loop in the update to our constraint or the custom constraint, otherwise it might error. So one is rig constraint, this is custom constraint. In custom constraint, so that's our list, and we're gonna loop through each of the rig constraint and custom constraint. Cool, just copy that code, make it custom constraint, and now we have a problem. So as you can see, I have defined these functions. Even though they are there, I'm trying to set them. There is some problem. Yes, so we don't have to add these modifiers firstly, and this guy needs to be an iCustom constraint, and now we can set the weight. So there you are. Once that's set, now let's come back here to the match rotation and just make the weight a slider by adding a range attribute. It's gonna act like a slider, which is much better for the weight. So as you can see, we just have these weights, and now we can assign all of these. We'll make them 0. I'm gonna drag these by locking the inspector first, and the right hand ones as well. So that's all of the direct rotation matching constraints. I'm gonna drag the iCustom constraint interface into interfaces folder. As you can see, I made a quite nice looking folder set. And I got an icon, so this icon you can just duplicate from the animation package. Well, you have to do that through the Finder or your Windows Explorer, because it doesn't allow here. So you can find and then duplicate and then put it in here, and then you can just set alpha as transparent and apply, because it forgets everything, and you can rename it through your Windows at first, so it all overrides everything in Unity, because for some reason it just doesn't allow that directly in Unity. But you will be able to find the packages folder and everything when you reveal in Finder or in Explorer. So as you can see, the weights are being modified. If I watch in real time, yep, it does go there smoothly. Not rather smooth, it doesn't matter if it's smooth or not. It has to be set directly. So now, as you can see, after adding this, you will see that we can actually change the thumb much more control. Can you see that? Yes. Everything is modifiable. Before using constraints, Unity would not allow me, because it's like a constraint. You can see it will not let unreal looking things happen, which it thinks is not real. So, but we can still override everything now. So cool, that actually works. That's it. Yeah, next thing we do now. Alright, so I've aligned all the hands, rotations and everything together. As you can see, it looks pretty nice and neat, and I can shoot just like that. Everything works. The hands are aligned, and except that I can notice some jitter on the fingers. That's because we're doing everything in light update, so we're gonna add a smoothing system. So let's add a tooltip for this variable, smoothing speed. So the smoothing speed used for smoothing results. We just comment out that and define a quaternion target rotation, set it to quaternion.slurp. Last constraint rotation, comma, to the quaternion.lerp, constraint.local rotation to the actual to match.local rotation, and this is going to be based on the weight. Then for the actual smoothing, we pass the smoothing speed time the delta time. Define a private quaternion, and that's just the last constraint rotation is equal to identity. Right, we have the target rotation. Now we can just paste that there as well. And for this one, we don't really, for first of all, we just want to say constraint.local rotation equals to target rotation. Last constraint rotation equals to target rotation. Alright, we paste that there. Now we can change it to rotation instead of local. So there you are, it's all rotation, not local rotation. And now we have much smooth results, and there's no more jitter as well. So that's exactly what I wanted to do. Let me just remove those comments now. So just remove those as everything is functioning as expected. Compile, and let's add this comment on top. Add a comment for this. Hold the last constraint object's rotation, as when you will try to get it, it's not gonna actually come correctly. So that's why we can't use direct lerping. I mean, why can't we just use the constraint.local rotation? Just can't, because it's returning the original animation. So anyway, just add summaries for the two functions. Check if the matching type is local. If so, then just want to use target rotation to the local rotation and just lerping stuff there. Just set the constraint.local rotation and the last constraint. Yep. So just gonna make some changes for animating. To begin with, we have all the animation clips done and the transition set up. We can only go from idle to shoot and from idle only to reload. We are not allowed to go from shoot to reload, which is what we want. Save, and let's just begin animating. So you can do this on your own, create the animations, and I'm not going to bore you by showing that all. So quite a few changes I've made already. So as you can see, we've got a particle system for shell eject effect. Alright, that's in the weapon base. Then we just have this basic if statement. If it is enabled, it's a boolean, which we have added. And that's in the scriptable object. I'll show you in a bit. Okay, that's all for the changes. Right now. Then the weapon SO, we have these changes. Eject on show, that public bool that we were accessing in the weapon base, and force mode and other stuff. Then we have serialized properties here, as you can see, for all three of those variables, and then we just get them as well in a similar way. We also draw them. So as you can see, only draw the projectile stuff if it is a projectile field. Otherwise, eject on shell shoot is still enabled forever, so that doesn't get affected. And that's all the changes, I think, for weapon SO, the scriptable object. And yep, let's just load the script now. And we have the OnShoot clip done. As you can see, so the clip is complete, and I've actually added 2 animation events. So this is a complete animation. You can see how it works. So we've got play audio clip, and we've got play shell eject effect. This is a simple function, an animation event inside weapon base, and it just plays the effect directly. As you can see, you just gonna play that, and that's all it does really. The animation is just gonna open the latch upwards and then pull it backwards, and then plays the function in the through the animation event, and that's it. Yeah, that's all the animation event does. I've set the time screenshot to 1.833 as that's the animation length. Alright, now I'm going to show you all the changes made to the scoping manager. You can see quite a few changes, coroutine states and things like that. We've got the listener we can assign as the event. We've got an OnShoot event. We check if the coroutine's not null. We start the coroutine. We have a summary for this one, just a basic one. It's the coroutine, which is going to set the state of its own state. The state basically. This is going to tell the variable, yeah, I am in progress or not in progress, and just mark it as complete once done. Here we have the same stuff. We just have used is scope instead and similar things. And I think we can just remove this. Yeah. So we'll just remove this small else if here. As you can see, they're similar. Doesn't matter if that. So we can just delete that and that. So there you are. And in the on naming, we have just got the basic stuff, except that now we have not in progress, then only we scope. And we call a function with net on name handler. Check if the coroutine is not running, then we do this, and the scope is false. With on naming exit handler is called. and you can see the function between an aim handler and or exit handler. You can pause and just write that down, and the on check for scope, and the rest is all same, I think. So no other changes, and I just added that for testing. Alright, loading scripts. Okay, so let's add instance of scripts, which is gonna actually give us access to the main camera brain, CinemachineBrain basically. So we can say CinemachineBrain instance. Let's go. It's gonna be singleton based. Let's create a len list. I'm sorry, I don't need that. And that's why I'm gonna be creating this. A public static CinemachineBrain instance. We use Cinemachine because we need that. That's our instance. We define an awake function, that's what we need. Instance equals this. Secondly, we remove the start functions no need, and the update. Now let's make use of it. So how to do that? Well, we needed it for the scope manager. We're gonna use the blend stuff, the blending speed and things. So let's define some blending variables. So CLI field, private float, camera blend time. If you go down here, we're gonna add the values over here. So as you can see right now, if I don't have any reference ready, so let me just try to get a reference first. So the brain instance, CinemachineBrain. Okay, if I say CinemachineBrain, so we don't have any real way of getting the thing. So let's just define a public CinemachineBrain, get brain or get CinemachineBrain, and we can say return get component CinemachineBrain. So whenever it wants us, we just gonna pass that in, and we need that component. So if you add this to the camera and doesn't have the Cinemachine, it's gonna auto add it. Let's just add that to the camera now, and go back to scope effect and try to use it. So firstly, we can use CinemachineBrain instead of instance. Alright, Cinemachine camera brain, and on the initialize function, we can just assign it directly using the instance. So we can say CinemachineBrain instance dot get instance dot get CinemachineBrain, and then we just use the stuff in there. So firstly, we define the blend time. So I think the blend time is named as default blend, as you can see. So if we go into default blend, m underscore default blend, and then we have more m variables. I think m are the variables you are allowed to modify. The rest you shouldn't modify. I don't know what it means, because you got in this one as well. I'm going to change that m time, so m underscore time, because I know it works. So, and that variable up there, that is going to be assigned to it. Again, in default blend, we're going to assign the m style, and that's going to be the style. So let's just get this and define enum up here. CLI is private enum, the enum that they defined for us already, the style, the blend definition. There you are, and we can just pass that in instead. And where is it gone? So there you are. Then the m default blend custom curve. So we need to define an animation curve if somebody wants to use that instead of the camera blending style. If it's custom, then only. Otherwise, it's going to be useless. So there you are. We just assign the curve. So now this function, the weapon's going to automatically assign all the smoothing and speeds and things. So let's just go there. And let's see everything which seems okay. Now we can see that everything should work. So let's set the camera blend time and the thing to ease in. If you change the camera blend time, it changes there as well. So that means it works. And as you can see, why it doesn't actually go into fight with the weapons, that's actually because we have a basic if at the top of the update, and it returns if we are not converted. Now let's try to swap the weapon. I will fix this, don't worry. Maybe in the next video or somewhere later. So as you can see, this one is snapping directly because I have set to 0 and works. Cool. So let's just fix some issues like assigning the correct stuff. So I'm going to go with ease in and 0.3. Assign a shell eject effect, as we don't have that. Then we can create one for this one, the cartridge eject effect. You can drag that from the Unity Engine particle system for both your sniper and the normal ones. And for each other weapon you can add that, so it's quite simple. Alright, So we have a face slow, it does work, and you can do cuts, you can do whatever you want. So it all does work. So as you can see, I can apply it to the prefab now. Before I finish doing this with it, I just want to position the cartridge effect somewhere where it makes sense. Maybe somewhere, maybe. And yeah, it's pretty okay. So if I go interact with it, let me just try to find a better pose to interact with. There you are, got it. And yep, you can see those that cartridge effect actually coming out. It's like playing in effect. Apply the changes and everything seems to work, so we can save. And yeah, so now the script's gonna be changing vignette stuff and everything else. It's like a complete scope manager. Still have some things to do though. And here I am with the reloading animation done. So as you can see, we have OnShoot, we have reload. I duplicated the OnShoot, and because quite a lot of things were similar in there, so you can see. So if you focus, you can see that OnShoot is similar to reload. So I duplicated the OnShoot and renamed it to AWM reload and deleted the original one and then assigned it in the animator, and then of course made it proper. So you've got the mag taking out and all the other events needed for this to work. So that's the complete animation. As you can see, I just duplicated, but you can't be seeing that, of course. I'm just telling you. I also assigned the correct time, so 4.9 is the correct, and the current M also is correctly assigned now. Alright, so I made quite a lot of changes to weapon base. Here you are, not a lot of changes though. So here you can see, because it wasn't functioning well. So we were checking if the left hand should be the one, the parent, so that we were doing something which weren't working. So now it works. And here I wasn't using spawn mag to try, instead I was doing try get components, so it was failing. That's all. In here we have actually defined a full GUI layout, some more stuff as you can see for shell ejection creation, and that's because we just added a new element and we needed it. Cool, that's it. It's just a variable up there, private, and set to null. Now let's just clean up some things for this script, make it variables. Let's add a new region, general. Got general stuff here. All of this is like weapon events or weapon mechanics or whatever. So I'm just gonna put that all in that small big region, so that's quite jumbo. And say we're out. And loading script. So that's the weapon base. In order to make things better, I actually made quite a few changes to this as well. So as you can see, we have on reload coding handler coding. We've got a coding state for the on reload as well, because reloading wasn't working. Assign the event as well, and a reload function, a reload coding as well. Let's just add a region here, scope system pausing. So basically pauses the scoped, you can see. This is a new function. It's quite similar. It's the on reload coding. It just does everything similar except that it's all now for the on reload. And the function that calls it passes in reload animation time, and the same, this custom number that I've made, it minuses from the camera blend time times 1.25. So that's quite helpful to prevent breaks and stuff. Then I have added this long thing. It basically slabs the rotation from the rotation normal to the weapon transform rotation multiplied by the Euler minus weapon the transform rotation Z. It's smooth because I've used some lerping, as you can see, slapping at a speed, and that's because we wanted to do it at all times. It works with the reloading nice and smooth. Now define a new variable, the private float camera smoothing stuff, and we can just camera rotation smoothing speed and use that instead of just a direct magic number. And this code here you can see is some more stuff. As you can see, check if the bool that we have stored is different from the actual one, set our bool to the actual one, and check if the new value is false. This means that it was true and now it is false, so we can call the event that should be invoked when we exit clipping. Check if we are scoped and not clipped. This is quite a big thing here, you can see. Scope is true and weapon is clipped is false, and some code not in progress. And I'll just make that and so that it actually makes sense. enable aiming virtual camera so that we are in the aiming mode, and enable vignette effect so we can see the effect. Disable it, and disable vignette, disable virtual camera only. That's the update function, most probably. Alright. Here you can see we've got OnShoot exit function. This literally checks if we are true, then we're just gonna set the vignette to active and the scope to true, and call the vignette awning handler. Alright. And yep, everything else is quite similar. Got two if statements: if we are clipped, then return, and other things, similar stuff, except that we were now setting the coroutines. If you had noticed, you could actually make my video slightly slow-mo so you could see more things slowly. And now we can try it out, so you'll see that when we reload we have like delay or whatever. I mean, we pause similarly, but right now it looks like my reloading is not happening because I did not set the ammo, so you must make sure the ammo is less than the magazine so that you can actually reload. And there you are. So we are reloading, and that's quite fast actually. Has speeded up the video quite fast actually. So some bugs have arrived and we're gonna fix them all. And firstly we need to go to the play controller, find the handle reloading. We need to use the gunshot timer to help us out in this case, because sometimes the vignette effect is coming on, or rather we are reloading, we're able to reload when we are already shot and we did not just come out of the thingy. So we're gonna just clean this up and make the raycast be the last thing to do, and just add a new statement. So gunshot timer should be lesser than or equal to 0, otherwise we are not allowed to reload until that happens. And yep, that's one bug fix. Hopefully it will work. So 1000 lines. Well, let's go. Reach 1000 lines. Okay. And you can see if I reload, nothing's going wrong. And during reloading, if I aim or anything I do, it's all okay. And other weapon is also quite good. It doesn't seem to have any problem. You can shoot over there. Now let's just come out of play mode and go to the scope effect manager again. As you can see, we are assigning it on the load coroutine and on shoot coroutine. The rest the same. Okay. So just adding a field that will help our other weapons actually work as well. This is the bool, which is gonna ask animation on shoot is equal to false, and we can add a tooltip to make you understand what I mean. Basically, this is enabled, means that every time we shoot, there's gonna be the time between shot will be used and delayed. Basically, it's gonna stop scoping. But some weapons just don't have that problem, so we just keep that bool for that weapon. We're just gonna do if animation on shoot is false, return on both cases. Save, and we're done. Let's try it out if it actually works. I mean, yep. And we can enable this on that weapon and disable as by default, so we don't need to do anything on the other one. So it's loading, and yep, we've loaded. So as you can see, this one actually has a delay, but if I go with the other weapon, so that's what I actually want to test. Come on, interact. If I aim now, I can shoot without having any jitter on my black effect around the screen. Sometimes, it was disabling, enabling quickly, and it was quite noticeable. So now that's not needed. So I actually forgot that we don't need this here. So just delete that away. Only for on shoot, right? All right. Now we can load again, and it works. It should work. Let's get a look. Let's interact. Let's aim, and perfectly fine, as you can see. Shoot, and we should be able to reload also if we do. Shot is also shot correctly. As you can see, we reload when we start reloading, then we are kicked out of the scope mode and we are actually back in after it's done. So that's pretty much the end, and if you want to use projectile, you can actually use projectile, but that's up to you. I'm gonna still continue with raycast for the sniper. Maybe later I'll think about projectile. And of course I need to just fix this up. So as you can see, we need to have and on both of the on aim and on aim exit cogene conditions. If you just have a look at that, because I found out that it was having some issues, like it would show the vignette effect sometimes for no reason, and you can just make it a prefab as it's done. And here you go, this is the outro. So we have our simple reloading system, OnShoot, and the vignette system, complete scope system. And if I shoot up there, it stops. Something similar like Sniper Ghost Warrior. Yep. And the vignette effect's not coming on for no reason, by mistake even. So as you can see, I can get out of aim and come in. Cool. So that's it for the video. See you in the next one. But before you go away, please consider liking and subscribing. Thanks for watching.